as we talk of events, we are talking about subsets. So, we have this definition here. Event A is a subset of B if and only if event B occurs whenever event A occurs. So, if event A will occur, that would mean that event B is also occurring. Since this definition would mean that the elements of A are in the set B, of course, when this occurs, when this event occurs, the entire event B should be occurring as well. And since we're talking about events as subsets, let's look into the different set operations so we can liken them as well to events in probability. Let's take a closer look. There you go. So, when we talk of a complement of a set, that would usually mean that every element in the universal set except the elements in set A. In probability, that meant that event A does not occur. In intersection, these are the common elements between sets A and B. So in probability, intersection would mean that both A and B occur. Union is the collection of all elements of A and B and both in A and B. So that would mean that either A or B or both occur. And this will be helpful for us in determining what is the actual sample space, what is the actual event given certain situations. Let us have a specific example here. So we are asked tossing a coin 3 times. This is our experiment, and we let event A, one head occurs, B, the first 2 tosses are tails, and C, all three tosses are tails. We are asked to define and describe the following sets. So first, let's have, maybe we can get a closer look. There you go. So, tossing a coin 3 times, we already have seen in the previous video its sample space. So let's have that. We can have all heads. Then the first 2 are heads, the last one is tail. Tail in between, or tail first, then 2 heads. Or 2 tails first and a head. Tail, head, tail, head, tail, tail, and all tails. So we are asked to define and describe the 3 sets here. So the first one is B complement. B is the event that the first 2 tosses are tails. So therefore, we need to find all the elements of the sample space that the first 2 tosses are not tails. Because it's complement, it should be not tails. So we'll get head, 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 tail, head, tail, head, tail, head, head. Tail, tail, head cannot be because that's B. The first 2 tosses are tails. I'll have tail, head, tail, head, tail, tail. I cannot get this because the first 2 tosses are tails. So there we go. The definition of B complement is it's the set containing these elements. So to describe it, we can say that these are the events wherein the first 2 tosses are not tails. Pause the video and try to see if you can do numbers 2 and 3. So, we are asked to find A intersection C. A, one head occurs, and C, all 3 tosses are tails. Now, if you're going to think about it, how can we have an event wherein one head occurs and there's a common event with all 3 tosses are tails? Event C, all 3 tosses are tails, it's just this outcome. So we cannot have one head here. So there is no intersection, or there's no common outcome between event C, all 3 tosses are tails, and one head occurs, which is actually all of this here above. Since there's no common element, or the set containing the intersection of those 2 sets is actually a null set, or an empty set. Meaning there is no event that it will happen at the same time. One head occurs and all 3 tosses are tails. So, For letter C, we're asked to find A complement union B intersection C. So first, to make it easier, let's find A complement and B intersection C. There you go. Let's just place it like that. So A complement would be the set of outcomes wherein one head occurs. So that would mean that I will just need to get the set of elements wherein not one head occurs. So that means I can have actually no heads, this one, or two heads, or three heads, as long as it's not just one head. For B intersection C, we have B again. First two tosses are tails, then all three tosses are tails. So if we're going to look up, the first two tosses are tails. That is just this outcome and this outcome. What's common in C, where it's just all three, it's just all three. So B intersection C has only the element T, T, T. And it's already actually in A complement. So therefore, we can say that A complement union B intersection C is just simply A complement, which has the set T, 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 H. This should be H, H, T, H, T, H, T, H, H, and H, H, H. In other words, this set can be described as the set of outcomes wherein it's not just one head that occurs. Now, most of our experiments will be assumed to be equally likely. So in an experiment, two or more events are said to be equally likely if, after taking into consideration all relevant evidences, none can be expected in preference to another. So for example, when we toss just a regular coin or a fair coin, we would know that its outcomes would just be either a head or a tail, and that's it. When we know the die is fair, it can just simply be 1, 2, 3, 4, 5, and 6. If we know that in this event, all outcomes are just as equally likely to happen, there's no preference that this will happen more than the other one, then those events are said to be equally likely. And most of the time, in probability, we have those assumptions that there are events wherein they are equally likely to happen.